single linked list. Before it, we know linked list is the types of linked list. So one is single linked list, next is double linked list, and then we have circular linked list, and then we have circular double linked list. So now we will talk about specifically about single linked list. So simply we can say it is a type of linear non-primitive data structure. Linear non-primitive data structure. So earlier we have also talked about why it is classified under linear and why it is a non-primitive. Now let's understand the structure of single linked list. So a linked list consists of a node, a group of nodes. So let's say this is a node 1. It consists of two components. First component is named as data, and next component on this component is we conventionally call it as a next. Here data means it stores some value. Next means it stores next stores address of next following node. Next following node. We'll understand it with an example. So let's say this is one node, this is second node, and this is third node. This is fourth. Okay. Let's say the information in it is 10, the information in it is 20, the information in it is 30, the information or data in this node is 40. This is a node 1, this is node 2, this is node 3, this is node. So how these all nodes are connected is by this fashion. Always the first node is called as a head node and last node is called as a tail node. And so this is the data first node. And what this component or what this consists of is, so let's say address. Address of this node is, let's say, 101. Address of this is 102, and address of this is 104, and address of the last node is 103, 104. So what this consists of is address of next following node. So this is stores address of next following node. Stores instead we can say points to address of next following node. So the next following node address is 102. So here we will have 102. And in same way for node 2, this component, in this component, so it stores the address of next following node. It is 103. So here it stores 104. And it does not, this is the last node, and it is not pointed to any further next node. So the address in it is updated as null. So this is a simple example of single linked list. We generally call single linked list as just linked list. Okay. So yeah. Now let's understand it programmatically. programmatically how the structure of a node is written. So we'll use the structures concept. This already we have learned it in C. Struct node, instruct node. So this is the structure of node we are talking about. So it consists of two fields. So one is a data field and other is a next field. So the data field is of type, let's say it has int data, and this is the next. There is a next variable. So what is the data type of it? The data type of data is int. And what is the data type of next? It is simply as next is pointing to next node. So this is as this is pointing to a next node. So the data type of it is also a structure of this node. The structure of this node is the data type of this next. So we can write it as struct node star next. So star next means we can access the address. So what is this next means? It points to the address of next following node, right? Next following node. Next following node in a linked list. So we'll understand later theoretically about this single linked list. So here we can define it as this way. So a single linked list is a fundamental data structure used in the computer science to organize and store a collection of elements called nodes. So a collection of nodes to organize them and to store them. So how we manage them is with the help of this linked list. In a single linked list, each node contains two components, a data and a reference or link. So here I said this is data, this is known as next. So there are other names, like we can also call it as a link, or we can call it as a reference node. So name convention can be anything. So in general, populistic is the next. So it consists of two components. One is a data component, and other is a reference or link to the next node in a sequence. So the last node typically points to the null reference, indicating the end of the list. So always the last node, the next it points to is null, because there is no further node, so there is no address that can be updated. So next, key concepts and terminology related to single linked list. So one is node, we have understand. So it's a fundamental building block of linked list. So what is simple linked list? It is a group of nodes. Arrangement of group of nodes is simply a linked list. Next, it contains a data and a reference to the next node. And next, it will be what is head and what is tail. We have already discussed. Starting node of a linked list is known as the head. It is used to access the entire list by following the links from node to node. So in general, to do any traversing. So in general, to do any traversing, so we'll use this head node. So if I want to traverse to the next node, so we'll simply write head arrow next. Means we'll be traversing this node too. So in this way, so it's used to access the entire list by following the links from node to node. So from node to node, we can traverse using this head node. And the last node in the linked list is known as a tail node. The tail link point to null, indicating the end of the list. Next, what is the next pointer? So this reference or the pointer in each node that points to the next node in a sequence. So it simply points to the next node and it stores the address of the next node. Next, what is traversal meaning? So the process of moving through the linked list from the head to tail, visiting each node in a order is known as a traversal. So simply traversal means first I will be visiting node 1, then node 2, then node 3, node 4. So visiting from starting of node to ending node in a linked list is simply known as a traversal. Next, what is empty linked list? A linked list with no nodes. In this case, the head is typically set to null. So that is why programmatically, so here we can add extra thing like struct node star head is equal to null and struct node star tail is equal to null. And initially, with no creation of any nodes, there will be null. So the head and the tail are pointing to null. So this is how we simply define the node structure. What are advantages of single linked list? What are disadvantages of single linked list? So the main advantage of single linked list is dynamic in size. So which is like unlike array. So the main problem with array is it is having a fixed size. So here we can. So now I will be telling you how we can add a linked list. So here we have 4 nodes. Now to programmatically in linked list we can also be able to add the next node. So how we can do, we will see in a little while through program. Next, memory efficiency. So because the memory is allocated as nodes are needed, making efficient use of memory. So if I want to store only 4 data points, means I will be using only 4. So in array, if we create a 5, so let's say 20, 30, 40. So created array size of 5, but I am using only 4 blocks. So one is wasted. So unlike in linked list. So insertion and deletion. So efficient for insertion and deletions at the beginning and then the middle of the list. Coming to disadvantages. So traversal is the issue because we can only traverse in the forward direction. We can't travel in the reverse direction. It is very difficult. So to solve this problem only, we'll be using the double linked list concept. And the second disadvantage is the random access. So lack of direct access to arbitrary elements. To access an element, you must traverse from the head. So if let's say I have 50, so I have let's say 10 nodes in a linked list. I want to access a particular node. So what we need to do is we need to always come from the starting node and go on traverse. Even to access the last node, I should be coming from the starting node.